Hi everyone, so in this video we're just going to go through the first test, the mid-module exam which you did slightly before Christmas. What I'm going to do is go through the questions one by one. The idea is that I want you to have your papers open next to you so that you can compare what you got compared to what the answer should have been. I will try and point out some errors which people made along the way, some common mistakes that people make, so that if you are going forward, for example, for a resit, then hopefully you can identify where common errors were made, and then hopefully you won't make the same errors again. So let's have a look at question one. Now question one was all to do with basic algebra. Realistically, these are just testing fundamental skills in the module. So there's no reason why you shouldn't be able to get 100% on these questions. They are just basic expansion, factorising and simplification of algebraic terms. So the key word here for question 1A is to fully simplify. Common mistake that people made was that they tried to simplify, and it definitely did do the right thing. For example, they expanded it or factorized it. However, they didn't go fully. So in other words, it wasn't looking simpler compared to what they started with. So in this case, I want to try and reduce the number of terms to make it look a little bit smaller and a little bit simpler. So for question A, part 1, we have 3 lots of x plus 4. So this is just an expansion question. So we can expand the first bracket to be 3x plus 12. Then a common error here was that people forgot to include the negative 2 and just treated this as 2 times by this bracket. So as a result, you should get negative 2 times x, which is negative 2x. And then again, common mistake that people made was they didn't do negative 2 times 5 to get negative 10. Instead, they just did 2 times 5 and just got a positive 10 there. So it is a negative 10. And then you've got 4 times by x plus 6. So this is 4x plus 24. Now, this is expanded, but it's not fully simplified yet. We need to go through and collect together the like terms. So namely, we have a 3x, a negative 2x, and a positive 4x. So that, if we add all those terms together, should make 5x. And then if you have a look at the numbers, we've got a positive 12, a negative 10, and a positive 24. So again, if you add all those things together, you should get a positive 26. So the final answer there should be 5x plus 26. Hopefully a nice and easy 2-mark question if you just expand and then collect together the like terms. And I think a large number of people actually managed to achieve that. The next question, so again, we're still fully simplifying. We've got 2 brackets, however, the second bracket has got 3 terms in. So just treat it systematically. There's a couple of ways that you can do this. You can either use like the happy face and sad face method, or you can actually draw out a little table. So I can put 3x and a positive 5a down here. And along the top of that table, I can then put all the 3 terms in the second bracket. So 9x squared, then a negative 15ax, and then a positive 25a squared. And then you just go through and expand each individual term. So for example, here would be 3x times by 9x squared, and that should give you 27, and then an x cubed. So be careful to multiply the 3 times the 9 to make 27, and the x times the x squared makes x cubed. Then you have 3x times by negative 15ax, so that's going to give you negative 45 from the numbers multiplied together. And then be careful here, you've still got an a, however the x times the x is going to make the x squared. So it's negative 45ax squared. Then you get 3x times by 25a squared, so 3 times 25 is 75. And then x times by a squared is going to make a squared x. Then we're going to do the bottom row, so we're going to do 5a times by 9x squared. So 5 times 9, that's going to give me 45. Then I've got a times by x squared. Then I've got 5a times by negative 15ax. So 5 times negative 15, if you need to use a calculator, that's fine, but it is negative 75. And then a times a makes a squared, and then I've still got that times by an x there. And then finally, the last term, 5a times by 25a squared. We're going to have 5 times 25, which is 125. Again, if you need to use a calculator, that's fine. And then an a times an a squared makes an a cubed. Now we're going to end up basically adding all these terms together. So if I like, I could actually put a plus there and a plus there as well, just to remind me it is a plussing, it's a positive number. Then I just go through and I can see there's some cancellations which can occur. So for example, I can't do anything with the x cubed term. So there's no other x cubed term in my expansion here. So in other words, that's going to go on the final answer line. But then if you have a look, I've got a negative 45ax squared and then another positive 45ax squared. So when I add them together, these are going to end up cancelling. Equally, if I have a look at the a squared x terms, there's a positive 75a squared x and then a negative 75a squared x later on. So as a result, these two things will cancel. And then there's no other a cubed terms, so therefore I'm just going to get a plus 125 a cubed, like so. Okay, so nice and easy 2 marks. One of the marks was for a valid expansion method. The other mark was for the final answer, so realizing there's that cancellation which should happen. A lot of people made errors, very basic arithmetic errors when you're expanding this thing out. And so as a result, they didn't end up making that cancellation. Okay, so just accuracy mark, be really, really careful because these are easy marks, so you shouldn't really be losing anything here. Okay, let's have a look at question 3. Now, not many people got this question. In fact, I saw all sorts of dodgy mathematics going on. For example, they saw 2pq and a negative 2pq there, and they end up cancelling them off. Absolutely cannot happen, okay? The only way that you can cancel off is if there was just a 2pq on its own there. But because we're adding terms on the denominator, we cannot do any cancellations. So as a general rule of thumb, the only time when you can do this cancellation method is when there is just multiplication alone on the denominator. In this case, there's an addition going on, so as a result, you cannot cancel, okay? So what we're going to have to do instead is do a factorization. So I'm going to treat the numerator and denominator separately. You can see that on the numerator that there is a p in both terms and a 2 in both terms. So as a result, I can factor out on the numerator a 2p, which then leaves me with q minus 2p on the numerator. Okay, so a q minus 2p on the numerator. If I do the same thing on the denominator, you see that there is a q in both terms, so I can factorize that out. And then as a result, the factor which is left will be q minus 2p. And then from here, you can realize, there's a q minus 2p there and a q minus 2p there. Here I can cancel because there is a multiplication happening here. There's a multiplication happening, so therefore I can cancel. So as a result, the final answer should just be 2p over q, okay? All right, have a look at question B of part 1. This was a nice, easy, straightforward question, okay? But people made arithmetic errors as we went through here. So you see here, I need to make x the subject of the formula. In other words, I need to try and isolate this x up here. Now, the easiest way of doing this is to first of all take away 17. So we're going to get y minus 17 on the left. And on the right, we'll just end up with x over 5. And then from here, I don't want x over 5. I just want an x on its own. So I'm going to have to multiply both sides by 5. So as a result, I'm going to get 5 lots of y minus 17 is equal to x, like so. Okay? So nice and easy mark here. If you wanted to expand this, you could leave this as 5y minus 85. That's also fine. But that's the final answer. So just be really, really careful here. A common error that people made was at this step to this step, they multiplied by 5 and then they achieved 5y minus 17, which is absolutely not the case. Absolutely not the case. There needs to be 5 lots of y minus 17, okay? Because it's 5 times the whole thing on the left-hand side. All right, then finally, we need to write this as a simplified fraction. So again, this is just exploiting our ideas of indices here. First thing that I'm looking at is the negative power, and I realise that that is just a reciprocal. So 1 over 16 to the 3/4 is fine. Now be careful here, it's positive 3/4 as the power now, because I've dealt with a negative by dealing with it as a fraction. Then from here, I can realise that the fractional power in the denominator is just the same as a root. So I can write this as 1 over the 4th root of 16, and then raise this to the power of 3. Now, this wouldn't be enough to get the full 2 marks. If you got it to this point here, you would have got 1 mark because you've exploited ideas of laws of indices, but you haven't simplified the fraction. This still looks messy, and there's still more evaluation you can do. Now, if you wanted to, you could absolutely stick this into a calculator. So for example, in this case, I could just go onto my numbers over here. Now I'm looking for the empty root button, which is this button here. So it's the number just above the x, the empty power. Obviously you might have a different calculator, so it might be a different place. But to access that button, you can see it's in blue. It's usually on yellow on a Casio calculator, but I'll need to click Shift and then click that button. It brings up an empty root. Here I'm going to type 4, then I'm going to use the right arrow and I'm going to type 16. And then I want to raise that all to the power of 3. So just make sure that you right click here, because I don't want my cursor next to the 16. because if I do that now, it's going to end up inside the root, but I want it outside the root, so I'm going to click to the right, then I'm just going to click the cube button, and then hit equals, and you realise it will evaluate for you. It's 8. So as a result, the final answer here should be 1/8. Okay, so let's have a look at question 2. So this is on surds and indices. Question 2a was mostly well answered, so I'll just go through this one quickly. A common error that people made here is either they made an error when they cancelled down the surd, so for example, they didn't quite get the right number outside of the surd, so the integer number, or they just typed this into a calculator straight away and they got the right answer. Now, just to verify this actually, I'm just going to stick this into a calculator to show you that you can use the calculator to get the right answer. So if I use this button here, you can see this is the square root button, and if I just go 150, and remember to type the right arrow to move yourself outside the surd, then type minus square root of 54, and if I click equals, it will automatically simplify this down. However, if I just wrote 2√6 in the exam, I shouldn't get full marks. In fact, in this case, I was fairly generous because I gave a seen or implied mark. However, if you just wrote down 2√6 in future, you will not get the marks because I just assume you used a calculator and you didn't show any mathematical knowledge there. So the way which you should have done this is considered both root of 150 and root of 54 separately. So remember, the whole idea here is that you're looking for two numbers that multiply together to make the number underneath the square root. One of them has to be a square number. So by that, I mean if I look at 150, I realise, 25 goes into that number. In fact, 25 goes in 6 times. And then if I simplify this down, I can say that's the root of 25 times the root of 6. And you realise that the root of 25 is just 5. So the final answer here should be 5√6. If I do the same with root of 54, again, you might be able to recognise that 9 goes into 54. In fact, 9 goes in 6 times. So if I type that as 9 times 6, then as a result, I can simplify that to root 9 times root 6, which breaks that down to 3√6. And then, of course, remember that I'm doing a subtraction of these two things in the original question. So 5√6 take away 3√6 is indeed 2√6. Okay, so nice, easy 2 marks there. Again, show the working systematically. So show that you've tried to simplify root 150 and show that you've tried to simplify root of 54. Okay, question B. Again, you can verify in your calculator what the final answer should be. Remember, it is just a verification step. It is not valid for the final answer. So if I bring the calculator up again, I can use a fraction button, which is this one here. And then if I go 4 minus the root of 5, and I'll need to exit out of that surd and then come on the denominator by using the down arrow. And then if I take 3 minus the root of 5, and if I type equals, it will automatically simplify the final answer to 7 plus root 5 over 4. So if you're using a calculator, you can use this as a verification. However, if you just wrote down this final answer, you should not get 4 marks. Again, I was being quite generous this time. But in future, if you just wrote down that as the final answer, you would not achieve the full marks. So what you should be doing instead is utilising the conjugate. You realise, hang on a second, that 3 minus root 5, I can turn that into a rational number if I multiply by 3 plus root 5. And obviously, I can't just multiply by 3 plus root 5 willy-nilly. I have to multiply both numerator and denominator by 3 plus root 5. So as a result, I need to just expand both of these things out. So let's consider them separately. So I've got 4 minus root 5 multiplied by 3 plus root 5. Again, a common error here was to ignore the brackets. So basically they did stuff like 4 times by negative root 5 times 3 plus root 5. It just didn't make sense, okay, what you did here. So the way which you should have done it is taken the 4 and multiplied it with everything inside the bracket. So 4 times 3, that's 12. And then 4 times positive root 5, that's 4 root 5. And then if I take the negative root 5 and multiply by everything inside the brackets, I get negative root 5 times 3, which is negative 3 root 5. And then negative root 5 times positive root 5, that's just negative 5. It's negative root 25 if you want to, but that's the same as negative 5. And I can just do a quick simplification here. For example, 12 take away 5 is 7, and 4 root 5 take away 3 root 5 is just positive root 5. Okay, so that's looking good for our numerator. Now I need to consider the denominator. So I'm going to go 3 minus root 5 times by 3 plus root 5. Some of you might recognise that as the difference of two squares, so it's fine just to do 3 times 3 plus negative root 5 times positive root 5. But if I'm doing this formally, it should be 3 times 3 and 3 times positive root 5, which makes 9 plus 3 root 5. And then if I take negative root 5 times 3 and negative root 5 times positive root 5, that's going to give me negative 3 root 5 and then plus 5. So as a result, these two terms in the middle, they will just cancel. And that just leaves me with 9, sorry, that should be minus 5 there, because it's negative root 5 times positive root 5. So that should just leave me with 9 minus 5, which is just equal to 4. Hence, that's how I get my final answer there. Okay, so use the calculator by all means to check that you get the right answer, or at least give you some hints for where you should be aiming for. However, all the working has to be seen in order to achieve the full 4 marks there. Okay, and 4 marks I think is quite generous for that question. Okay, if I was producing this exam paper, I'd probably only give 2 or 3 marks there, but 4 marks is quite generous, and there's no reason why everybody should get the full 4 marks there. Okay, so question C of part 2, the final part of the surds and indices thing. A lot of errors were made here, and they were basic numerical errors, which are really, really not good. So just break it down systematically. So first things first, I'm going to consider the things inside the brackets. Now, just be aware there are more than one ways of doing this. So if you did this a different way, for example, you tried to produce a whole fraction inside the brackets, that's absolutely fine, okay? But in this case, I'm going to do it by simplifying the indices. So let's consider this thing here. Let's consider the ab squared times by the a cubed b to the negative 4. You realise there's a multiplication happening there, so therefore you should add the powers. It might help to realise that that power of a is just 1. So if you get a to the power of 1 times by a to the power of 3, that's going to give you a to the power of 4. And then if you consider the b's, b to the 2 times by b to the negative 4, you add the powers there, you get b to the negative 2. Okay? So that's the thing which goes there. We're still going to be adding. Let's consider the second term now. Now this is just a case of division, right? A fraction just means divide. So therefore I need to subtract the powers instead of adding them. So a to the 5 divided by a to the negative 2. So let me write that down explicitly so you can see what's happening here. This is simply the same as if I take 5 and I subtract negative 2. So 5 subtract negative 2. So in other words, be careful of the double negative, because this should be equal to a to the power of 7. Then, if I take b cubed and I divide it by b to the power of 1, then I'm just going to subtract the powers to get b squared. Okay, so that's the thing which goes inside the brackets. And actually, the mark scheme was very, very generous here, because if you got it to this point here, you would have achieved full 3 marks. Okay, so you would only have dropped 1 further mark, which I actually think is very, very generous. So if you got to this point here, you've achieved 3 marks. However, this is where the common error occurred. People fail to realise what you should do with the power of 2. The most common error, and I'm going to write this in red because you should not do this, was to distribute this 2 over everything inside the brackets. So in other words, they took 2 and multiplied it with the 4 to get a to the 8, and then b to the negative 2 times 2 to get b to the negative 4, and then a to the 7 times 2 to make a to the 14, and b to the 2 times 2 to make b to the 4. And that is absolutely not correct, okay? Because in this case, you've got an add in the middle. If it was a multiply in the middle, you could absolutely do what I've just done on the right-hand side. However, because you've got an add, you need to treat this as a binomial. In other words, terms that you need to multiply by itself. So in other words, you should be considering a to the 4, b to the negative 2, plus a to the 7, b to the 2. And then literally just multiply that by itself. So in other words, write it out again. So a to the 4, b to the negative 2, plus a to the 7, b to the 2. And then you just simply expand the brackets in the usual way. So you take this times this, this times this, this times this, and this times this. So in other words, you're just simply multiplying them out as you would normally, like an ordinary bracket squared. So remember, it's multiplication. That means you should add the powers. So for the first one, so that one times that one, you're going to get a to the 4 times a to the 4. So that's going to make a to the power of 8. B to the negative 2 times b to the negative 2. You add the powers there, and you should get b to the power of negative 4. And then if you consider the a to the 4, b to the negative 2 times a to the 7, b to the 2, let's see what we get there. So a to the 4 times by a to the 7 is going to make a to the 11. B to the negative 2 times by b to the 2, well, negative 2 plus 2, that's just going to make 0. So I'm just going to leave that as a to the 11 there. The b to the 0 doesn't need to be written. Then if I consider the rest, so a to the 7 b squared times by a to the 4 b to the negative 2, that's going to give me another a to the 11. And then finally, a to the 7 b squared times by a to the 7 b squared. Well, a to the 7 times by a to the 7 is a to the 14. And b squared times b squared, that's going to give me b to the 4. Now you just need to simplify this ever so slightly by realising there's two a to the 11s in the middle. So as a result, this should give you a to the 8, b to the negative 4, plus 2 a to the 11, plus a to the 14, b to the power 4. Okay, and that should be the final answer there. Okay, so like I say, most people got it to this point, so they would have achieved 3 marks, which I thought was very, very generous for the mark scheme. But they should have put this down as an expansion, which a lot of people failed to do. They struggled with. And as a result, you lost a mark, which is a real shame. Okay, so let's have a look at question 3 then. So this is a coordinate geometry question, okay? Coordinate geometry is one of the bigger weighted topics in this course. It's worth 20 marks overall, so it's well worth focusing your time on understanding what's going on here. And actually for this part, it was broken into part A and part B. Both parts were asking about perpendicular lines and how to find the equations and distances and gradients and lines and things like that. So actually, this question was only really asking 3 things: perpendicular lines, distances of lines, and gradients of lines. Okay, so if you got those sorted, pretty much you should have received 20 marks on this question. But unfortunately, nobody did because they made simple accuracy errors along the way. So let's have a look at question 3A. So we've been given the line L, so we're calling it the line L, passes through 2 points. So we've been given both points for A, however, we're missing a point for B. So in other words, K is missing here. K is just some constant, which we'll inevitably need to find later on in the question, okay? The line L is perpendicular, okay, so you can think about what perpendicular means, namely in the context of what we're interested in, the gradients must multiply together to make -1. Okay, or you can think about negative reciprocals. So in other words, M1 is just the negative reciprocal of M2. Okay, so that's what the perpendicular line here means. And we've been given the equation of the line which is perpendicular to L. So first things first, we need to find the gradient of line AB. Now most people jump straight in and they try to apply the formula rise over run. But of course you realise here that rise over run is not going to work because, okay, you've been given both coordinates of A, however you've not been given all the coordinates of B. In other words, K is still missing. So rise over run is not going to help you here because you don't have both of the coordinates, okay, or at least you don't know all of the coordinates here. So instead, we're going to have to use this second bit of information. Actually, surprisingly few people actually realised that they couldn't come up with a gradient equation because there's not enough information there. So they had to use the second bit of information. So the way to look at this is to look, hey, I've got an equation of a line, so therefore I'm going to rewrite this in the usual form. I'm going to write it in y equals mx plus c. So I'm going to get 3y is equal to -2x plus 12. And then as a result, I need to figure out, hang on a second, I don't want 3y, I just want y. So I'm going to have to divide everything by 3. So this should be -2/3 of x plus 12. Now remember, this is not the equation of line L. So a lot of people got it to this point, who attempted this method at least, got it to this point, and then they put -2/3 the final answer on the basis that that should be the gradient. But that is not right, that's not correct, because this is the line which is perpendicular to L. In other words, we need to find the gradient of the line AB. In other words, the gradient of the line passing through A and B, or the gradient of line L. So because it's perpendicular, we use the idea of perpendicular lines. We realise perpendicular lines should multiply together to make -1, or one should be the reciprocal of the other. So in this case, the gradient of the line L, or the gradient of the line passing through A and B, should be 3/2. Okay, so it's really important. Read the question carefully. Okay, in this case, you cannot use the direct gradient equation because there's points missing. So therefore, we're going to have to use the second point of information. And you know that it's perpendicular to the equation with 2x plus 3y equals 12. Okay, so the line AB is a line segment, okay, but it is passing through the, or it's the equivalent to saying what is the gradient of line L. Okay, let's have a look at part 2 then. So now we need to find the equation for line L. Now, spoiler alert, if you didn't get the correct answer here, as long as you used your gradient consistently for the rest of the question, then you would still achieve full marks, okay? So, find an equation for line L. We need 2 pieces of information. We need the gradient. So the gradient we've just found is 3/2. We need a point which lies on the line. So we need an x value and we need a y value. Now, B, in this case, lies on the line, but it's not going to help us here because we don't know what the x-coordinate of B is. So as a result, we're going to have to use the point A. So in other words, we're going to have to use x equals 3 and y is equal to negative 8. Okay. So now we just use our traditional form. Now, in this case, it needs to be left in the form ax plus by plus c equals 0, where a, b, and c are integers. So I think it makes sense to use the form y minus y1 equals m times x minus x1. But if you wanted to use y equals mx plus c and rearrange it, that's absolutely fine. Now at this point here, I'm just going to simplify slightly. For example, I'm going to treat this as a plus 8 so that I don't confuse myself later on. And actually here, you could multiply the second bracket by 3 over 2, but what I'm going to do instead is multiply everything by 2 because then I get rid of the fraction. So if I multiply everything by 2, I get 2y plus 16 equals 3, lots of x minus 3. And then I can expand the bracket out on the right-hand side to get 2y plus 16 on the left and 3x minus 9 on the right. Then all I need to do is just make it equal to 0. So in other words, I'm going to pull the 2y plus 16 on the other side. Equally, you could have pulled the 3x minus 9 on the other side as well. Either way is fine. So I'm just going to write this on the answer line. So you should get 3x minus 2y, and then negative 9 take away 16, that's just going to give you negative 25 equals 0. Okay, so 3 marks for that question for a fairly standard question. Again, I just want to re-emphasize, even if you didn't get the correct gradient for part 1, as long as you used it consistently for part 2, you could still achieve all the 3 marks there. Okay. Now, a common error that people made here was they failed to leave it in the correct form. For example, they left it in the form y equals mx plus c, which is not what they're asking for here. So as a result, you wouldn't achieve the full 3 marks, but you would achieve 2 marks. Okay. Equally, some people did leave it in this form. However, a, b, and c were not integers. So for example, they kept the 3 over 2 in, and then they left everything as a fraction, which is not what we're looking for. An integer means a whole number. So if you don't leave it in the form which is required in the question, you will not achieve that final accuracy mark. Okay. Then for part 3, we need to determine the value of k. Now there's a couple of ways of doing this. If I scroll up to the original question, b is the point k and negative 2, and that lies on the line L. So as a result, we could use x equals k, and y is equal to, what was it, negative 2. Yep, negative 2 here. And then substitute it into either part 1, so in other words, we know what the gradient is, so we could use that one, or we could substitute it into our equation down here. Either way is fine, okay? Now I'm actually just going to do the gradient method, so I'm going to say rise over run, which in this case is going to be the difference in the y's, so it's going to be negative 2, take away the y coordinate from our other point, which was point A, so we're going to take away 8, divided by the run, which is just going to be k, take away the x coordinate of our other point. If I scroll up, you can see that that is just 3. Okay, so it's going to be k minus 3. Now, I actually know what this is equal to. So a lot of people got this, and maybe they simplified it down to negative 2 plus 8, which is going to be 6 over k minus 3. But then they were like, how on earth do I find k from this? Well, hopefully you realized that you could just use your gradient value from part 1, because that should be equal to what we've just calculated down here. So this should be equal to 3 over 2. And then from here, you can solve this equation. So for example, you can multiply, you could cross multiply basically. So multiply 3 by k minus 3 and multiply by 2 should leave you with 12 is equal to 3, lots of k minus 3. Again, remember to use the brackets. Common error here is people forgot the brackets here. And then expand this out, so we get 12 is equal to 3k minus 9. And then solving this, we get 3k is equal to 12 take away 9, which is just equal to 3. And then if you divide that by 3, you should end up with k is equal to 1. Oops, my mistake. I've made a small mistake there, so ignore that line there. That's slightly wrong. So if I add 9, I should have added 9 to both sides here. So 12 plus 9, which is going to give you 21, equals 3k. And then if I divide by 3, you get k is equal to 7. So sorry, just a small error there. Doing calculation live and never my favourite activity. But you should have got k is equal to 7 there. Okay. Good, so a common error here is that people just got completely lost by the time they got to point 3. If you didn't get part 1 and part 2, you could still access the marks for part 3. However, yeah, I think people kind of struggle with part 1. then as a result, they struggled with part 2 as a result because they didn't use the correct gradient value, or they got completely confused about the gradient value. And then by the time they got to question 3, they were just completely lost altogether. And actually, by the time they got to question 4, because there's another part to this question, it says you find the length of the line segment AB. The trouble is, we now know what A is. Okay, so A is going to be 3 and -8. And we now also know what B is as well, because K we now know is 7. So we get 7 and -2. So as a result, from here, you can just use your standard formula to calculate the line segment. Again, I just think people got to this point and they were so lost in the weeds at this point because they didn't get the correct answers out, that as a result, they just didn't attempt this question altogether. But what you should have done is use Pythagoras basically. So it's the change in the x coordinate squared plus the change in the y coordinate squared. So if I calculate that, I'm going to do the change in the x, which is 7 take away 3, all squared, plus the change in the x's, which is -2 take away 8, take away -8, all squared. And then if you calculate this, you get 7 take away 3 squared, which is 4 squared, plus -2 plus 8 effectively, which is going to be 6 squared. And then square root all of that. And then if I just carry on down here, 16 plus 36 square rooted makes the square root of 52. If you wanted to simplify that, you absolutely could. You could treat that as root 4 times 13, which is going to give you 2 root 13. But either one is fine there. It doesn't say that you have to give your answer as a simplified line segment. Simplified surd. So either root 52 or 2 root 13 is there. If you gave it as an approximate decimal, then that is absolutely fine as well, because it doesn't specify what the what form you have to leave it in. To be honest with you, I just tend to leave it in surds because it's one less thing to type in a calculator. So root 52 or root 13, 2 root 13 is there. And then carrying on for part B, this is one which people really struggled with. And I think it's just because it was given a diagram and people just didn't really understand what the diagram was saying. So here we've got 2 lines. We've got line L1, which is this line here in red, and we've got line L2, which is this line here in blue. And you can see it's labelled as such. So here's L2 and here's L1 just to help you. Now L1 and L2 are perpendicular to each other and intersect at the point 2, 4. Okay. Given that L1 passes through the origin, so it is the red line that I've highlighted there, can you find an equation for L2? Common mistake here, people only found an equation for L1. They didn't find the equation for L2. So make sure that you read the question carefully. It does say here that you need to leave your answer in the form y equals mx plus c. Okay, so remember that we can think about this as 2 perpendicular lines. So as a result, if we find the gradient of L1, which we can absolutely do because we have 2 points which lie on the line, we can't find the gradient of L2 because we only have 1 point to work with for L2. But we can find the gradient of L1. So the gradient for L1, I'm going to call this M1, is going to be equal to 4 take away 0 divided by 2 take away 0, because remember the origin is 0, 0 here. So 4 divided by 2 basically is going to give me the gradient of 2. But that's not the gradient I want, that's the gradient of L1. I want the gradient of L2. So as a result, I need to use perpendicular gradients again. So the gradient that I want is going to be -1/2. Okay, so the gradient I want is -1/2. And then I just use a fairly standard line equation to figure out what the equation of L2 is, because I know that 2, 4 lies on the line L2. So as a result, I have m is equal to -1/2, x is equal to 2, and y is equal to 4. Let's put all this together, and we'll actually use y equals mx plus c because it's asking for y equals mx plus c in the question. So I can say y is equal to, well, y in this case is 4, is equal to m, which is -1/2, times by x, which in this case is 2, plus c. I can then rearrange this to figure out what the value of c is. So I've got 4 is equal to, well, -1/2 times 2 is -1, add c. So if I figure out what the value of c is by adding 1 to both sides, I find c is equal to 5. So putting it all back together then, I have y is equal to my gradient, which is -1/2, times by x plus my c, which I've just found is 5, and that's a nice and easy 4-mark question, okay? The key to unlocking this question is understanding what this diagram is saying. Again, a lot of people tried to find the equation of L1 and they got completely lost, okay? Read the question carefully. L1 passes through the origin and 2, 4, and you need to find the equation of L2, okay? If you think about it, You cannot find L2 unless you've been given L1 as well, because you cannot find the gradient of L2 unless you've also been given a line perpendicular to it and some more information about L1. Okay, so that's how to answer that question. Once you unlocked and realised the fact that L1 and L2 were perpendicular, you can find perpendicular gradients, and then as a result it's just a fairly standard find the equation of a line question. So actually so far we've had 2 questions which have found the equation of a line. We've had this one, which is worth 4 marks, and we've had question A part 2, which was also worth 3 marks. So 7 marks was just, can you find the equation of a line? Okay, and again, for some reason people just seem to struggle. So this is just basic stuff. Make sure you practice this. Okay, and then part 2, so we're on the last part now of question 3. So hence, or otherwise, find the perimeter of the shaded region. Now, I'm just going to draw out that shaded region again from the diagram above. So this is what we've got from the diagram above. We want to find the perimeter of the whole shaded region, so everything, all of this in here. So as a result, we're going to have to use L2 at some point. So L2, remember, has the equation y is equal to -1/2 x plus 5. And then if I draw on my x and y intercepts, sorry, my x and y axes, effectively I need to find the area of this region here. Now I know that this corner of the triangle is at the origin, so what I really need to do is figure out what this is and what this is. In other words, where's my x-intercept and y-intercept, because then I'll have a length down here and a length down here, and then I can think about how to find the third length, and then I've got the perimeter. So let's first of all find the y-intercept, because it's nice and easy. In fact, if you set y to be 0, sorry, if you set x to be 0, you just find y is equal to 5. So as a result, this height here is just going to be 5, which means that the length, or the height of the triangle if you like, is just going to be 5. To find the length of the triangle, so the bit across the bottom, you need to find the x-intercept. Remember, to find the x-intercept, you're just going to set y equal to 0. So I can solve this equation up here. I'll have -1/2 of x plus 5, and of course that's equal to 0. Now, just because I don't really like the fraction, I'm just going to multiply through by 2. That's going to give me -x plus 10 is equal to 0, because 0 times 2 is still 0. Then as a result, I can simply solve this to find x is equal to 10. So that point there is 10, which means that the length along the bottom is just 10 units. Now this is not quite enough to find the perimeter, because there's one length missing from my triangle, which is this one across here. It's the longest side, or the hypotenuse, of this particular right angle triangle. So actually in this case, I can just use Pythagoras to figure out what that is. So using Pythagoras, I've got the other 2 lengths. So I can say 5 squared plus 10 squared square rooted is going to be that final distance there. Let's just call it d, just for the sake of illustration. So 5 squared is 25, 10 squared is 100. If I add them together and take the square root, I find that d is equal to the root of 125. Okay. So therefore, if I want to find the perimeter, I'm going to have to add all of these sides together. In other words, 10 plus 5 plus the root of 125, which I've just found. So I'm going to write down here perimeter equals 5 plus 10 plus the root of 125, which, if you look in the question, it needs to be given to 2 decimal places. By the way, if people left their answer like this, I didn't score the full marks. Okay, so 15 plus root 125 is what you need to type in a calculator. So let's bring my calculator up and let's actually type this in. So I'm going to go 15 plus the root, which is this button here, of 125. And if I press equals, it's going to give me it as a simplified surd form. Remember, to convert from surds to decimals or fractions from decimals, I need to use this button here. On your calculator, it might say S to D. In this case, it says F to D, but it's basically a button usually about here. If I click that, it will give me it as a decimal. And again, if I just accidentally press that by mistake and I want to go back to surd form, just click it again. Okay, so I can click this as many times as I like, and it will convert between surds and decimals. But in this case, I want decimals, and it is to 2 decimal places. So I've got 26.18. I want to stop at the 8. I just look at the decimal next to it. It's 0, so I don't need to round that 8 up. So as a result, the final answer here is going to be 26.18. Okay. Not a hard question, but I think just people got completely lost in the weeds. Maybe they just didn't really understand what this question was saying. Again, it did depend on what you got for part 1. But like I say, if you got the wrong equation for line L2, but you still showed an attempt to try and figure out how to do question 2, in other words, you used your equation for part 1 in part 2, you still would have achieved the full marks. Okay, so that was worth 6 marks. So it was a good chunk of the paper there. And for some people, that would have literally pushed them over into the next sort of grade bracket. Okay, so really, really important you understand that. Okay, so question 4 then, trigonometry. I actually thought this was a really fair question, really, really straightforward, but unfortunately we saw a lot of errors when I was going through and marking this question. So it just shows lack of practice or just lack of accuracy. Maybe it's also not understanding how to use the calculator as well. So again, as I've said many, many times in class, please, please, please make sure you get yourself a calculator and you're practiced with it. Okay, I think a lot of people made errors because they just were using the calculator for the first time in the exam, which was a real shame. Okay, so question 4a, the diagram on the right shows a square. Remember that the whole definition of a square is that all of the side lengths, let's call it S, are the same length. Okay, so that's S, that's S, that's S, okay? And we need to find the area of the square. Now remember, in order to calculate the area of the square, it's just going to be the base times the height, okay? So in this case, it's just S times S, which is going to give me S squared. So what I'm looking for to find the area is a value for S squared, okay? All right, now I've been told information, I've been told the diagonal of this square is 8. Now hopefully if you've drawn a diagram like, or you've annotated the diagram like this, you would realise that actually this is just a right angle triangle, okay? And this longest side is 8 and the 2 remaining sides are exactly the same length. So because I'm working with the lengths of my right angle triangle, hopefully you just applied Pythagoras. Nice and straightforward, Pythagoras' theorem here. So as a result, I get S squared plus S squared is equal to 8 squared. I realise I get S squared plus S squared on the left-hand side, so that's 2 lots of S squared is equal to 8 squared. 8 squared is 64, so as a result, if I do 8 squared divided by 2, just to get S squared on its own, I find myself 32. If I wanted to, I could take the square root and find the side length was equal to root of 32 and do that extra step and say, oh, hang on a second, I've got root 32 times root 32, but actually, as we've said above, all we need there is just S squared to find the area. So because I found S squared here, the final area should just be 32, okay? This I thought was a really fair 3-mark question. In fact, 3 marks is very, very generous here. So the fact that people just didn't spot Pythagoras, didn't really annotate their diagrams at all was a real, real shame, I think, because this was a really accessible question and it was just basically Pythagoras just hidden behind the layers. All right, let's have a look at question B. Again, a really standard question, and it's a real shame that actually a high proportion of people didn't get this, and I don't understand why. Okay, because what we've got here is an angle, and we've got 2 sides of this triangle. So we've got the opposite to this angle, the 3, and we've got the adjacent to this angle, the 5. And if you just label up that triangle and realise, hang on a second, I need to find theta. This is a standard question which we have done hundreds of in class, so really there's no excuse not to get it. We can just realise we're using the tangent here. So we can say the tan of my angle, tan of theta, is equal to the opposite divided by the adjacent, which is just 3 over 5. And then people got it here, but they didn't know how to complete this, okay? Now realise that you need the theta here, so as a result, you're going to need to take the tan inverse of both sides. And again, I think people just made complete errors with this question because they didn't know how to use a calculator. So let's spend a little bit of time making sure we know how to type into a calculator. We want the tan inverse function first of all. So if you come along here, you see sine, cos and tan are all next to each other. And then just above that, you've got sine little minus 1, cos little minus 1 and tan little minus 1. So in this case, you want the tan minus 1, which you achieve by typing shift and then going tan, and that brings up the tan inverse, okay? And then we need to go 3 over 5, so I type my fraction button, and I go 3, and then I click down to type 5, then I just type to the right to get out my fraction, close the bracket, and press equals. And it does ask for our answer in degrees, so in this case, it's to the nearest degree, so I don't want it in decimal places, so it should be 30, and then you realise here that the 0 gets rounded up to 1 because the next digit is a 9, okay? So this should be 31. Now, for some people, they got weird numbers like 1 point something or other, and that's just because their calculator wasn't set up properly. So if you look here at the very top of your calculator display, my one says a D, and your D should come up as well, because if you notice, it's the nearest degree, so the D stands for degrees. If you see an R there, that means your calculator is in radians, and we've talked about what radians mean as well. So obviously every calculator will be different, but in my calculator, I think it's shift and then setup and then you can see that there's a couple of options here. There's one for degrees and one for radians. In this case, I want degrees, so I'll click 3. Obviously, if I wanted to convert this to radians, I would just click 4. But in this case, I want degrees, so I'm going to go 3. And then as a result, my number will come up in degrees there, okay? All right, let's move on then. So now this is talking about sectors. So we've got the diagram below shows a sector of a circle with a radius of 6 and a center of 0, or a center of O rather. We need to calculate we know that the angle here is 125 degrees. First things first, really easy 1-mark question, and I'm really in despair of the fact that people didn't get this, because converting degrees into radians we have done so much practice of, and it just shows a lack of practice, a lack of proficiency with this. So converting degrees into radians, a couple of ways you can do it. You can just remember that pi is equal to 180 degrees, so pi radians is 180 degrees. If I want 125 degrees, I need to first of all figure out what 1 degree is worth, which I can find by dividing both sides of the equation by 180. Because clearly if I divide the right hand side by 180, I'm just going to get 1. And then the right hand side, I'm going to get pi over 180. And then you realise, I don't want 1 degree, I want 125 degrees. So again, you can scale this up by saying I need to multiply this right hand side by 125. But of course it means I'm also going to have to multiply the left hand side by 125 as well. So if I take pi over 180 and times that by 125, that should be my final answer here, okay? So pi over 180 times by 125, and again you can use your calculator. By the way, if you left your answer like that, you would have scored the mark, okay? I was really generous there. But just to show you how to simplify on your calculator, we're going to type a fraction first. So we need pi, which is this button down here where my cursor currently is. So I'm going to have to go shift, press this button, it brings up pi. Click on the denominator of this fraction, and I'm going to type 180. Exit out of the fraction by clicking to the right, and then timesing that by 125 and clicking equals, and it will give it to me as a simplified fraction nice and easily. So 25 over 36 pi. Now, if your answer needed to be left to a decimal, so it doesn't specify here that you wanted to leave it as a fraction. If you wanted to leave it as a decimal, again, you could use this button here, the F to D on my calculator, probably S to D on your calculator, and you'll get it as 2.18. Okay, so either one was absolutely fine there. Okay, and then for part 2 of question B, it says find the area of the sector. Find the area of the sector. So again, find the area and the arc length. Really, really straightforward questions, which we have done so many of in class. And so I was really, really disappointed the fact that most people just left this question blank, which I don't really understand, or at least they only half attempted this question. It was worth 4 marks, and it was a standard question which everybody should have got because we've done so many questions like this in class. Again, just lack of revision, I think, just meant that people just didn't get this. So find the area first of all. Again, remember to find the area of my sector. You think about it as I've only got 125 degrees out of the full circle. So that's 125 degrees out of the full 360 degrees that should be in the full circle. And then I multiply this by how I find the area of an ordinary circle, which is just pi r squared. So if I times this by pi times by r, which in this case is 6 squared, then as a result, I can just give my answer in terms of pi, so I don't have to do any more work here. I just bring in my calculator, type this in nicely, so I just go 125 over 180, and then I go times, and then I need pi again, so I'm going to go shift and pi. Oops, I didn't mean to press that, so I'll just go back. Yep, so let's press that again. Oops, I pressed the wrong button again. So let's go 125 over 180 times by, and then I need pi, so it's going to be shift and then this button, so I pressed the wrong button before. And then I'm going to times this by 6 squared, so 6 squared there. And then your calculator will simplify this down nicely for you. Okay, so you should have got 26 pi there. Oops, sorry, another mistake which I've made. It should be 125 over 360, so I typed that into a calculator wrong. Let's try it one final time. It's still practice for typing into a calculator. So yeah, that was just a mistake there which I made, I think. After going for about 50 minutes, it's starting to get a bit tiring. So 6 squared, and if I put it equals, that's better. 25 over 2 pi. So that's my area. 25 over 2 pi there. And again, I can just come down and just write this in my area line. So 25 over 2 pi is my final answer. Again, the question does say give your answer in terms of pi. So because it's giving your answer in terms of pi, I do not want it as a decimal. If it did say it's 2 decimal places, I just type 39.27 basically. okay? But in this case, in terms of pi, I need that. Okay, now to find the arc length, it's basically the same principle. You realise the arc length is just a proportion of the circumference. So remember, it's 125 over 360. Then I'm going to times this by 2 pi r because that is the circumference of my circle. So as a result, I'm going to do this times 2 times pi times r, which is 6. Again, I just type that in a calculator. Let's hopefully get this one right. So I'm going to type the fraction, and I've got 125 over 360 times by pi, which is that one, times by 2. Oops, I put it in the wrong order, but that's fine. Times 2, and then times 6. Then as a result, this comes out as 25 over 6 pi. Okay, and again, if I wanted this as a decimal, which I don't in this case, because I should have lost a mark if I left it as a decimal. Again, I was being fairly generous in this exam with marking because I was kind of in despair by this point, at the fact just basic things just were not being done properly. But it does say give your answer in terms of pi, so it should be 25 over 6 pi, not as a decimal, okay? So I actually think that this question here, question 4, was a really, really fair question. It was just testing basic ability. So as a result, if you didn't get 100% of this question, okay, 4A, we haven't done examples like that in class, but hopefully utilising the knowledge and the skills and things that we've looked at in class, you should have absolutely got this question just by thinking about it and making appropriate annotations. But question B is a standard question, and the fact that people were not able to get these 2 marks is a real shame, okay? And I think it just shows lack of revision more than anything else. So please make sure you practice this. Again, with question C, standard question, converting degrees into radians, everybody should have got this, okay? And then equally, this one here, we have done lots of questions direct like this in the class. We could have asked more complex questions than this, but it wasn't. It was just standard. Find the area of the sector, find the arc length of the sector. The fact that people were just not getting this question is actually really, really worrying, okay? So everybody should have got at least close to 10 marks here, and it's a real shame that people didn't. Okay, let's move on to question 5, which is quadratics. Again, a big proportion of the class. Big proportion of the paper. Question 5A was a really standard question. It's just solve these quadratic equations, okay? So if you're practiced with solving quadratic equations, and you could factorise all of them, by the way, then there's no reason why you shouldn't have achieved full marks here. So let's just work through them gradually. So question 5A part 1 is just simply factorising. So it's going to be x, let's have a look, x plus 5, x minus 3, equals 0. Remember, you're looking for 2 numbers that multiply together to make negative 15 and which add together to make 2. So as a result, here you can solve it and you can find x is equal to negative 5 or x is equal to 3. Common numeracy error here, and actually there was a lot of numeracy errors in this question, which meant that people lost marks on it. You didn't think about the negatives carefully, okay? So please, please, please make sure you double check. It's not difficult, it's just basic numeracy accuracy. You need to make sure that you get the right numbers for positive and negative. So most people got 5 and 3, but they didn't think about the negatives carefully, so as a result they made a mistake there. Okay, let's have a look at question 2 then. So we're going to take away 4 from both sides to make this equation equal to 0. So we get negative 4 equals 0 like so. And then this is a non-monic quadratic. So remember, you're looking for 2 numbers that multiply together to make not negative 4, but 3 times negative 4. So in other words, you're looking for 2 numbers that multiply to make negative 12 and which add together to make negative 4. Again, common errors here. People get 12 and get 4, but they don't think about the negatives. It's really important you capture the whole of those numbers. Okay, so don't ignore the negatives. Okay. And then as a result, we can set up our 2 brackets. Remember, you put 3x at the start of each of them. And then 2 numbers that multiply together to make 12 and add together to make negative 4. I think 6 and 2 will work in some combination. I want negative 4, so it's going to be negative 6 and positive 2. Again, common numerical errors there, just not think about the negatives carefully. And then I just need to divide this bracket by 3. So it's obvious here, I think we should divide the first bracket by 3. That leaves us with x minus 2, lots of 3x plus 2 equals 0. And then from here I can just solve these 2 brackets. So I get x is equal to 2 or x is equal to negative 2 over 3. Again, common mistakes there. I'll repeat it again because lots of people made the errors. Make sure you get your negatives right. That's where people made the errors. So make sure you get your negatives right. Okay, now this question here, what you could do is realise, hang on a second, I've got a negative x squared there. I don't like the negative x squared, so I'm going to multiply everything by negative 1. So that's going to leave me with positive x squared, positive 3x, negative 10, and 0, if I multiply by negative 1, remains at 0. that's going to be a lot easier to try and solve. Okay, so now I'm just going to factorize this into two brackets, and it's a straightforward monic quadratic. So remember, I'm looking for two numbers that multiply together to make -10 and which add together to make +3. So I probably need 5 and -2 here. So x minus 5 and x plus 2. And then if I solve those two equations, I get x is equal to 5 or x is equal to -2, like so. Okay. So again, really straightforward questions, but people made errors with the negative. Okay. All right, and then the final question, I need to make it all equal to 0. I think the obvious way of doing that is moving everything from the right-hand side onto the left-hand side, okay? But you can do it left to right, doesn't really matter. So if I take away 5x squared from both sides, I just get a single x squared. -7x, now I'm taking away a 6x, so that's going to give me -x, and I'm going to take away 6 from both sides as well. So that should be the equation which you're going to be ending up with. And then as a result, I just need to factorize this into two brackets again. So multiplying together to make -6, adding together to make -1. I think 3 and 2 is going to work in some combination. So again, just be careful of your negatives. So I'm going to end up with -3 and +2, which means my two roots are going to be x equals 3 or x equals -2. So actually part A was a really, really standard question. Okay, it was just solving quadratics. Again, if you were not proficient with solving quadratics, then you would have lost a lot of marks there. I don't think anybody wasn't. I think the main errors occurred just because people weren't careful enough with their negatives, okay? So common errors there, just be careful with the negatives, spend those extra couple of seconds just double checking and make sure that your negative numbers are working. Again, just poor numerical accuracy, which has been a common theme throughout this whole paper, to be honest with you. And I think for most people, if you made common numerical accuracy mistakes, then actually you could have achieved at least another 10, maybe 15 marks just through those simple errors. Okay, so about an hour in, or about halfway through the paper, so we're doing all right for time. Question B, nobody got this question correct. In fact, the highest number of marks was for 1 mark awarded here. So everybody tried to do the wrong thing, basically. First thing which we need to do is realise the division should be treated as a multiplication. So we get x squared minus x minus 2 over 6x cubed minus 24x. Then we're going to multiply this by 30x plus 3x squared minus 6x cubed, all divided by 2x squared minus 3x minus 5. Actually, this is where most people scored their marks. Okay, so like I say, the highest number of marks for this question was 1, and this is where the 1 mark was awarded just for doing that. Okay, so it's quite generous, but it was a mark nonetheless. But then everybody from here basically tried to expand these brackets out, which is completely the wrong thing to do, because expanding this out is clearly not going to make this any simpler, right? We need to simplify it, which means we need to write it with fewer terms. In this case, if I expand it out, well, look, I'm going to end up with x squared times by x to the power of 3 over here, which is going to end up with like x to the power of 5. Like, how on earth do I deal with that? How on earth is that going to be made simpler? Equally on denominator, I'm going to end up with another x to the power of 5. It's just not going to work if I expand it out. So instead, I should have factorized every single component. There's 4 factorizations to make. So I'm going to have a look and see if I can do it. I'm going to need a little bit of space, but I'm going to see if I can squeeze it in down here. So first things first, I'm going to try and factorize x squared minus x minus 2. That's just nice and simple. Put it into 2 brackets. Okay. So it's going to be multiplying together to make -2 and adding together to make -1. That's going to give me x minus 2 and x plus 1. Okay, so that's going to factorize there, right? Then if I look at the next part, so actually I'm going to color code this so you can keep track of where I'm at. Now if I look at the denominator of this, okay, well this has got 2 x terms in, and actually it's got 6 in as well. So I can factorize this nice and straightforward into a single bracket. So if I take out 6x, that's going to leave me with x squared, and I'm going to have minus 4. Now actually I can factorize this further, because if you have a look, this is a quadratic equation, which means that I should be able to factorize this into 2 brackets theoretically. And in fact, if you thought about this a little bit more, it's difference of 2 squares. That's a square number, that's a square number, and it's a difference because I'm subtracting. So therefore I'll have 6x, lots of x minus 2 times by x plus 2. Okay, so that will fully factorize to that. Okay, I'm running out of colors slightly, but I think we've got enough. Let's have a look at this one now. This one was the most difficult one to factorize, I think. So we've got 30x plus 3x squared minus 6x cubed. Now here I've got an x in every single term, and in fact there's also a factor of 3 in every single term as well. So I'm going to factor out a 3x, which is going to leave me with 10 plus 1x minus 2x squared. And then as a result, that is just a quadratic which we can factorize. In fact, to make my life a little bit easier, I'm going to factor out a negative as well. So that's going to become a positive, that's going to become a negative, and that's going to become a negative, and I'm just going to put the negative out the front. Then that way it just works out a little bit easier, and then as a result, I just need to work with negative 3x, that's dealt with, and then it's just 2x squared minus x minus 10. And again, I can factorize that into two brackets. Just for the sake of time, you can obviously use the extra answer space at the back, but just for the sake of time, this will factorize to negative 3x times by 2x minus 5 times by x plus 2. Okay, so again, just using that in the usual way, it's a non-monic quadratic, just factorizing that in the usual way will give you this. And then, and I'm really running out of space here, so I'm just going to make this a little bit smaller. I'm going to do this one in orange now. Okay, so I'm going to factorize this. So I've got 2x squared minus 3x minus 5. If I factorize that, again, just for the sake of time, I'm just going to go through this quickly and just do it directly. But it's the usual method of factorizing into two quadratic brackets. So what do I end up with? I end up with 2x minus 5 and x plus 1. Okay, so that's everything factorized. So you should have gone through here and factorized all of those four terms. Okay, there was a mark for each factorization. Okay, and one mark obviously for changing it to a multiply. But when I put it all back together, and I'm just going to write it over here just for the sake of space, if I change the red thing, I end up with x minus 2 times by x plus 1. If I change the blue thing, I'm going to end up with 6x times by x minus 2 times by x plus 2. If I change the green, I'm going to end up with negative 3x times by 2x minus 5 times by x plus 2. Again, I'm just copying and pasting pretty much what I've done down here on the left-hand side. And if I change the orange thing, I'm going to end up with 2x minus 5 times by x plus 1. And of course, I'm multiplying this, so I could just write this as a single vinculum over like that. Okay. And then all I need to do, because I'm multiplying everything together, here I can make my cancellations. Okay, so I'm multiplying lots of factors together, so I can make some cancellations. I'm going to do my calculations in purple, because that's the only colour that I haven't used so far. So have a look. I've got an x minus 2 and an x minus 2 here. They factorise, cancel nicely. I've got an x plus 1 and an x plus 1 here. They cancellise nicely. I've got an x plus 2 and an x plus 2 here, and a 2x minus 5 and a 2x minus 5 here, which means that all of this cancels down to negative 3x over 6x. Oh look, the x's and x's also cancel, and 3 over 6 cancels down to 1/2. So the final answer here should actually have been negative 1/2. Okay. Hopefully now you've seen it, you realise that's not actually that difficult. I think it puts people off. If you did the multiplication, if you did the expansion, that would have put you off because it would have ended up with something really messy, really horrible, and yeah, you just wouldn't have got close to the final answer. So actually nobody spotted here that you should have factorised every single thing because you're basically doing lots of quadratics here. Okay, again, not a difficult question, but maybe not necessarily obvious if you haven't seen this before. Okay, so as a result, this was pitched at the higher sort of end of the paper. All right, but question C, on the other hand, is an absolutely straightforward question. And I was really, really disappointed that very, very few people actually even attempted this question, given the fact it was worth 5 marks. Like 5 marks for questions that we've done loads of in class. And the fact that just people just did not get anywhere close to sort of an answer here is a real shame. Okay. So again, I just think it's just lack of revision, to be honest with you. And I know some people have been working really, really hard on the papers, and obviously there are other factors as well, but this is a standard question. Like, come on guys, you should have got 5 marks here. Okay. So we need to sketch the graph of this curve, clearly labelling the coordinates of the vertex and the exact values where they intersect the coordinate axis. So again, standard question. First things first, we're going to find the y-intercept. The y-intercept is found really easily just by setting x is equal to 0. So if I set x to be 0 here, we just find y is equal to 5. Okay. So literally just go through and just set x equals 0 in that equation. Okay, now we're going to find the x-intercepts. So the x-intercepts, slightly more tricky to find on the basis they don't factorise, because we've done lots of questions with factorising so far in this theme. But if we set y to be 0, we're basically trying to solve x squared plus 8x plus 5 equals 0. Now obviously this doesn't factorise, but you have other techniques which you could have used to solve this, and I think the quadratic formula is completely fair here. So we're going to use x is equal to negative 8 plus or minus the square root of b squared. And remember, the quadratic formula is even in the beginning of the books. There's really no excuses here. 64 minus 4 times a times c, so that's going to be minus 20, all divided by 2 times a, which is 2. Again, I'm just going to type this in a calculator just for practice, but you can simplify this further. Now, just for the sake of this, it doesn't specify whether it wants to be... oh, it does actually. It specifies here it needs to be an exact value, so not decimal places. It needs to be an exact value. So if I bring my calculator up, I'm just going to type big fraction. I'm going to go negative 8. And remember, it's plus or minus. So the first time around, I'm going to type plus, and then square root of 64 minus 20. You could do that in your head. It's just over 44. And then a denominator of 2. And it will simplify it down automatically for me to negative 4 plus 11. So plus root 11. And actually, if I just go back, and again, I can just type back here, bring my cursor up here, press delete, and change that to a negative, and then that comes in as negative 4 minus 11. So that should be negative 4. Okay, so those were the two roots there. Those are the 2 points where they cross the x-axis. The only last thing to find is the vertex. So to find the vertex, remember, we just complete the square. So there's a formula for completing the square, which I have given you, but actually I just find it easier to just complete the square as you would normally. So I go x plus 4, all squared, minus this thing squared, so that's minus 16, and then plus 5. So as a result, this comes out as x plus 4 all squared, and that's going to be minus 11. So the two roots, the vertex of this particular parabola is going to be negative 4 and negative 11. Again, a really standard question that we have done plenty of in class. Okay, so negative 4, negative 11 there. Final thing to do is just to sketch it. Remember, the number in front of the x squared is positive, so it's going to be a happy face parabola. I know what this point down here is going to be. It's the negative 4, negative 11, which I've just found. Okay, and then I just fit my axis on. So I'm going to end up with an x-axis here. This point is going to be negative 4 minus root 11. That's a smaller value. And this point here is going to be negative 4 plus root 11. That's a bigger value. And then I'm going to have a y-intercept of 5. So I just basically need to make sure that I get the right numbers in the right place. In fact, the y-axis in this case is going to end up over here. And that's going to be at 5. Now, if you were sitting there and you weren't sure where the y-axis is going to be, just simply come back to your calculator and then just type this in as a decimal. So just change this to a decimal and you realise, you realise this is a negative number still. So negative, the negative value is a negative. And if I come back here and I change this to a plus, and I type this to a decimal, again, this is still a negative number. So both of the roots are negative. So as a result, they should be on the left of the axis, okay? Again, a really, really standard question. 5 marks is completely accessible here. The idea is that you get 1 mark for each of the processes. So 1 to find the y-intercept, 1 to find the x-intercepts, 1 to find the vertex. Then if everything's correct, you get that accuracy mark. And then if you've got a sketch which is consistent with the values that I've highlighted in red over here on the left, regardless of whether they're right or wrong, as long as the sketch is consistent with your values, you will get another mark there as well. So that's where the 5 marks came from. I saw all sorts of weird things going on with this question, which is a real shame. Like I saw straight lines being drawn, which you should have realised if you sketch this graph, you should get a parabola. It should be a curved graph, like a U-shaped graph. Again, really disappointing this question because it's a standard question that we've done plenty of in class. So well done everybody that got it, but realistically, many, many more people should have got this question right. I was really disappointed that you didn't. Okay, and then we move into the latter part of the paper. So question 6 and question 7 were by far the most poorly answered questions. I kind of understand that on the basis that you were probably running out of time a little bit, so you probably wanted to squeeze these in. But I mean, look, we're 1 hour, 10 minutes in. Okay, fair enough. I've been explaining things as I've been going. But I mean, the fact that we're 1 minute, 10 minutes in, 1 hour, 10 minutes in means that you should still have another 50 minutes to complete the remaining 2 questions. That should be more than enough time to complete it. Like I say, I've been explaining as we've been going through here. So as long as you're practiced and proficient with all of the methods in the course, realistically, you should be, this is completely fair to complete the question in this time. I think we just got to question 6, question 7, and a lot of people just left these blank, which is a real shame because that meant a lot of marks were missed, okay? Okay, so let's have a quick look at question 6, which is transformations of graphs. So we've got two diagrams below, f of x and g of x. There's two graphs here which have been drawn. All we have to do is just describe what transformations have happened to get from the top graph to the bottom graph. Okay, so to get from the top graph to the bottom graph, you can clearly see that this graph used to go up, but now it goes down. And then over here it used to go down, but now it goes up. So there's clearly been a reflection which happened. Hopefully you realise it's just a reflection in the x-axis. Okay, hopefully that's relatively easy to identify. So reflect in the x-axis. And there's one mark there. All right. But it's clearly not quite just a reflection, because if you have a look, this peak before it got reflected was at 1, but then after it reflected, instead of it being down here at -1, which would have just been a straightforward reflection, it's been pushed down here to -2. Similarly, this trough down here was at -1, but after it's been reflected, instead of it being at +1, it's up here at 2. So in other words, there's been a stretch in the y direction, like you've been multiplying by 2 in the y direction. So it's a stretch in the y direction, and the scale factor is just 2. So that's the second transformation which you should have identified. So stretch in y direction, I'm just going to type y dur for short, and then just a scale factor equals 2. Okay, so 1 mark for reflection or stretch. So if you identified either of those, you've got 1 mark. Another mark if you got at least 1 correct, and then the full 3 marks is if you got both of these transformations correct. Okay. Again, I saw all weird things going on here, like translations. This cannot have been translated, because if you have a look, this point, i.e. where it used to intercept the axis, still intercepts the axis here. Okay, and equally, that point matches up with that point, and that point matches up with that point. So the fact that the x-intercepts haven't moved means that it's exclusively reflection or stretching. Translation would mean these intercepts would have moved, okay? But they haven't in this case, so it's just a reflection or stretch. And then for part 2, I mean, the amount of people that left this question blank was really, really worrying, because at the end of the day, there's 4 options to choose from. It's basically multiple choice. Just guess one. The worst that you'll get is you'll get 0. But if you guess one, you'll have a 1 in 4 chance of getting the question right, okay? In fact, I don't think anybody got this question right, which is a real, real shame. Even though there were some people that got the translations correct up there. So, sorry, the transformations correct up there. So reflection in the x-axis means that there has to be a negative, and in fact this means that the negative should happen outside of the bracket, so it should be negative f of x, right? Stretch in the y direction, remember if it's a stretch in the y direction, it's multiplying by 2 outside the brackets. So as a result it should be -2 f of x, like so. Okay, so as a result the only option there which is correct is C. Okay, so you just have to write C there as a result. But again, nobody got that correct, which was really, really worrying, because it's I think if you're able to translate, if you're able to identify the transformations correct, you should have got that second part correct. Okay, now we're moving on to part B. So, by the way, I mean, I should have mentioned this earlier on in the paper, but parts, things like this, so part 1 and part 2, it means they're related to each other. So because this is all in section A, okay, and then part 1 and part 2, it means that they are related to each other. Now we're moving into part B, it means that this is no longer related to anything else. So it's a brand new question, basically. Almost, anyway. The curve y is equal to x squared is translated down by 3 units, or 3 units the negative x in negative y direction. State an equation for the transformed curve. Well, this is easy, right? You're just simply saying take y is equal to x squared, move it down by 3 units. So literally you're just going to have to take away 3 from the equation. So y is equal to x squared minus 3 is the correct answer there, okay? If somebody put y is equal to x squared plus 3, I did give them a mark, okay? Because you clearly identified you should be adding or subtracting after the x squared. If anybody put y is equal to x plus 3 or x minus 3 all squared, again, would not score the marks because it should have happened after the x squared, okay? But the correct situation here, y equals x squared minus 3. What I'm trying to highlight is that if you wrote this down, and you would have scored a mark, I think that's really generous because it's wrong, okay? But it's clearly identifying knowledge. So I'm trying to identify to you that method marks can still be awarded. It's not just the final mark that matters, okay? It's the methods as well. And then again, another brand new part to this question. So questions part C said, the diagram below shows the curve C with this equation. Find the x-intercepts. Like, okay, you might not have dealt with an equation that looks like that before. However, it's the x-intercepts. You know how to find the x-intercepts. You just simply set y to be 0. Now, some people expanded this out, which is completely the wrong thing to do. If you expand this out, you lose the kind of ability to answer this question. So you should end up with x minus 2 times by x plus 3 times by x plus 7, and that's all equal to 0. You can see that because you've got three things multiplied together, they all equal to 0. It's basically like a quadratic, except you've got 3 brackets instead of 2. So as a result, the x-intercepts, it does say coordinates, so I guess we should give them as coordinates, but you won't lose a mark if you don't. Should be 2, 0, negative 3, 0, and negative 7, 0. Okay, so those are the three coordinates there. Again, if you just put x is equal to 2, x is equal to negative 3, and x is equal to negative 7, you still scored all the marks, okay? I wasn't that fussy. But again, really, really easy question, and people were just leaving it blank, okay? Remember, x-intercept, set y to be 0. That's the key to unlocking the question. We've done so many questions like that in class. All right, part 2 then, so still related to the previous part. The curve C is transformed by a translation negative 2, 0, followed by a reflection in the y-axis. Find the coordinates of the x-intercepts, okay? So if a sketch helps you, that's fine, but actually in this case, you can use the sketch up here. So you've just found this point here is 2, this point here is negative 3, and this point here is negative 7. Let's just follow the transformations through. So it's translated first of all negative 2, 0. That means 2 to the left. So quite simply, all of these will jump 2 to the left, okay? So this 2 will go to 0, this negative 3 will go to negative 5, and this negative 7 will go to negative 9. However, there is one more transformation that's occurring. It's a reflection in the y-axis. So reflection in the y-axis simply means all of these points will just jump over here, and yeah, just basically jump over on the other side of the axis, because here's the y-axis here. Okay, so as a result, negative 9 is going to move to positive 9, negative 5 is going to move to positive 5, and 0 is going to remain at 0 because if I reflected over, it's just going to stay fixed because it's on the line. So the three coordinates should be 0, 5, and 9. Okay, and it's just the x-intercept, so 0, 0, 0, 5, sorry, 5, 0, and 9, 0. And again, if you just gave the x coordinates, that's absolutely fine. So x equals 0, x equals 5, and x equals 9 is also absolutely fine. But again, like if you got the first part right, the rest of these parts are really, really accessible. It's just following them through, okay? I think the issue is that because so many people missed part 1 because they overcomplicated it, or they just didn't realise that it was as easy as that, then as a result, they missed a lot of these marks here. Then the next part is just write an equation for the transformed curves. Well, again, you now know what the new x coordinates are going to be. You're not doing any stretches or anything like that. So the key here is to realise that, first of all, we're just going to take our curve and basically write them as roots. So we're going to have x plus 0, and then x minus 5, and x minus 9. Again, what I'm looking at here is this thing up here. I'm looking at the roots that I found in the first part. Again, if you got the wrong roots in the part 2, you would have still scored marks down here. So it would have looked something like this. However, we just need to be a little bit careful because we need this reflection in the y-axis. So remember, reflection in the y-axis means that I'm going to change my x value because in f of x notation, I'm going to have y is equal to f of negative x. That corresponds to a translation in the a reflection in the y-axis. So as a result, what I'm going to have to do is change my x's to be negative, and it's as simple as that. So I'm going to have y is equal to negative x plus 0. I'm just going to write that as negative x, then negative x minus 5, and then negative x minus 9, and that's going to be your final answer. Okay. Oh, not quite actually, because I need to make all of these positive because obviously I'm translating these over, so I'm reflecting these over. Okay. So hopefully everything's all okay there. Oh, sorry, no, I don't need those negatives. Sorry, what was I thinking? Yeah, so that's as simple as that. So that's the final answer there. So as a result, I do my translation. So I'm simply just using the roots up here, and then obviously I'm making these negative. So these should be the final answers here. Okay. All right, good. Hence, find the y-intercept. Well, if you just look up at what we found up here, the y-intercept is just going to be 0. Okay, because we've simply just moved it over to the left. Even if we do the reflection, we're still going to have one of the x-intercepts at 0, which means that by definition, the y-intercept should be 0 as well. So as a result, the final answer here should just be 0, 0. Okay, so there you go, 15 marks for that question. Okay, there were a couple of tricky things in there with sort of sorting things out, but there were also some really easy questions there. Like, I think that question, really easy. This question, really easy. It wasn't involving translations. This question, again, is just identifying translations from a graph, okay? So I think that was relatively accessible. Here, you can guess at an answer, even if you don't know. But yeah, if you follow that through, you should get this one. Okay, let's have a look at the last question then, and then we'll be finished. So at the moment we're 1 hour 20 minutes in. So 1 hour 20 minutes is really good for this paper. Still leaves us 40 minutes, which is more than enough. So we're working at the moment on about a mark per minute, which is about right. Okay, so 7a part 1. State the y-intercept of the curve y is equal to 1 to the power of x. Okay, y-intercept, remember, just set x to be 0. So actually we're using this skill of finding intercepts, like maybe 4 or 5 times during this paper. To find the y-intercept, you set x to be 0. To find the x-intercept, you set y to be 0. Okay, so in this case I just set x to be 0, so I get y is equal to 1 to the power of 0. Anything to the power of 0 is just 1. So as a result, the y-intercept is just 1. So you can write y equals 1 or 0, 1. Either one is fine. Okay, easy 1 mark. People were leaving this question blank. Again, I think time had a factor, but still 0, 1 is the correct answer there, just setting x to be 0. Okay, part 2 then. A curve is given by the equation y is equal to 3 to the x minus 4. State the coordinates of the intercepts of the coordinate axis and equation of the asymptote. So again, we're finding intercepts again. So again, we're using that skill to find the x-intercept. We're going to set y to be 0. So up here we've got 3 to the x minus 4 equals 0. We can rearrange this equation to get 3 to the x is equal to 4. And then to find x, remember x is the power. So to find the power, we're just going to use our logs. So we're going to say log to the base 3 of 4. You can leave your answer like that, or you can give it as a decimal. So just to show you how to find a decimal, there's a log button just here. We're going to hit that button and we're going to have 3 down here, use the right arrow and put 4. So if you wanted to use 1.26, that's also absolutely fine as well. Okay, but in this case, I'm going to find my x-intercept as log to the base 3 of 4. And then to find my y-intercept, I'm going to set x to be 0. So if I set x to be 0, I get y is equal to 3 to the power of 0 minus 4. Well, 3 to the power of 0 is just 1. So this is the same as 1 take away 4. So as a result, y is equal to 1 take away 4, which is negative 3. Okay, so there's my y-intercept. So x and y-intercepts are there. I won't put those on the line just because I'm writing fairly big for the sake of clarity. But those are my two x and y-intercepts. Then to find the asymptote. Now, it's a shame people didn't attempt this question because hopefully x and y-intercepts are relatively easy to find, like I've just shown you. But the asymptote, I appreciate, is a little bit more tricky to find. But actually, if you draw a sketch, it will fall out. So if you think about the ordinary y is equal to 3 to the x graph, it's a graph that looks like this. So it's a curve that looks like that. An asymptote, remember, and we have talked about this in class, is a line which the graph approaches. So in this case, this graph is clearly getting closer and closer and closer to the x-axis. In other words, it's getting closer to the line y is equal to 0. If I do y is equal to 3 to the x minus 4, well, you can think there, y to the 3x minus 4 just simply means move the entire graph down by 4. So as a result, this graph, the asymptote will also move with this graph. So if I just do a quick sketch, we're going to end up with something that looks like this. So if we're moving it down by 4, the asymptote will also move down by 4, so therefore the equation of the asymptote is y is equal to negative 4. Okay, so that's the equation of the asymptote there. So again, not tricky. A simple sketch and an understanding of exponential equations, which we've done a lot of in class, would have helped there. But simply just finding x and y intercepts, like everybody should have got that because it's just set y to be 0, set x to be 0. Everybody could have done that and at least got 3 marks. Okay. All right, let's have a look at part B then. Real shame with this question. Everybody should have got this question right, but only a small number of people actually did. And I think the reason being is because they just didn't understand how to convert logarithms into exponentials. Guys, this is a basic skill, like come on, right? 2 marks for this question. Everybody should have got 2 marks. Converting a logarithm into an exponential, we've done so many questions like this in class. Okay, so the most common mistake that people made was to realise that the x was not the base. So, sorry, the x is the base. But the most common mistake that people made is they wrote stuff like this. So they wrote like 3 to the x is equal to 64, or x to the power of, or 64 to the power of 3 is equal to x, or something like that. Just not writing things in the right form. In this case, the base, the number down here, is the x. The power is always what the logarithm is equal to. So whatever the logarithm is equal to is always the power. So you get x cubed, and then this is equal to the number inside the logarithm, so 64. That's the correct thing that you should have written down. The number of people that just didn't get this was actually shocking, okay? And then to rearrange this, you just take the cube root of both sides. So x is equal to the cube root of 64. Again, you can type this into a calculator, and I'll just show you how to do that. Some of you might know what that is. But if you come here, you might be able to see just a little root with a little 3 there. That's the button we want. So we're going to go shift and that one. Oops, shift and that one. That brings that up. And then if I go 64 and if I press equals, you find the answer is 4. Okay. Sorry, but that was a really easy 2-mark question. The amount of people that just didn't get that was really, really worrying. Okay. Now it does say to give your answer to 3 decimal places. So you could have written 4.000, that's fine. But it does say where appropriate. Here, 4 doesn't really appropriate to leave it to 3 decimal places, so 4 is fine there. Okay. All right, next one. Again, come on guys, we have done so many questions like this in class. The amount of people that just made really simple errors and actually only achieved 1 mark, or in some cases no marks at all. We've done loads of questions like this in class. It's just lack of revision, I think, the reason why people didn't get this. So the first thing to realise is that 4 can be written as 2 squared, and that's all being raised to the power of x. Then you've got 6 times by 2 to the x plus 7 equals 23. Hopefully you realise here this is 2 to the power of 2x minus 6 times by 2 to the x plus 7 equals 23. And then look at this, right? This power and this power related, one is double the other one, okay? So here, if I just go u, or whatever letter you like, is equal to 2 to the power of x, which actually most people did try, which is good, okay? But then they just made complete errors from here on in. So realise here that the 2 to the power of 2x is basically just u squared, okay? Because the 2x, 2 to the x is u, so therefore I'm squaring that to get u squared. Then I've got minus 6, well I'm not going to write 2 to the x anymore, I'm going to write u. And then if I want to make this equal to 0, because I recognise it's a quadratic, I'm just going to take away 23 from both sides. So as a result, I should get negative 16 is equal to 0. Then just really simple, solve your quadratic equation. Again, even if you made an error here, but you got a correct quadratic or a valid quadratic, and you tried to solve it, you would have achieved at least 2 or 3 marks. Okay, so really, really generous the mark scheme here, but I just couldn't award it because basic arithmetic errors. Okay, so let's factorise this. So we'll have u and u here. Let's have a look. 8 and 2 would work. Let's go negative 8 and positive 2, and then we get u is equal to 8 or u is equal to negative 2. So then I just go back to my original form, which is 2 to the power of x. So I've got 2 to the x equals 8 or 2 to the x equals negative 2. Well, hopefully you realise that if I raise 2 to a power, I'm never going to get something negative. So this one is not valid. And this one, if you're not sure how to solve this, you can use a calculator. Again, use your logarithms. So log to the base 2 of 8. So if I type that into a calculator, let's clear the last number. So we've got log to the base 2 of 8. And you realise that's just equal to 3. By the way, if I tried to type in negative 2 here, so if I tried to do the other one, it would have come back with a maths error. Okay, but in this case, the answer for the one which I need is 3. Okay, so x is equal to 3 only. Okay, sorry, but that was based on the fact that we have done so many questions like that in class. I was really, really disappointed the fact that people just either left that blank or just made really, really stupid errors, really, really sort of basic errors early on in the question. So it's, again, just poor numerical accuracy. People need to do more practice with these kind of questions. And then the last question on the paper, so we're currently an hour and a half in, so it's more than enough time to do these questions in the time given. We need to solve this logarithmic equation. Well, first of all, you realise on the left-hand side, you've got 2 logs being added together, so therefore you can multiply inside the arguments. So we'll have log to the base 6 of, we've got x minus 63 times by 2x plus 18. Again, some people got here, but then they just made really, really basic errors. For example, they tried to add inside the brackets, or they just got 63 times the 2x and didn't multiply everything else together. So just really, really basic numerical errors going on here. Okay, now this is simplified as far as we can using logs. So now we need to put it back into exponential format. So we get x minus 63 times by 2x plus 18 is equal to, well, the base in this case is 6 and the power is 5. Okay, so we should have got 6 to the power of 5. If we wanted to, we could have worked with 6 to the power of 5 using our calculator. So 6, then we use the empty power button to the power of 5. And that's going to give us 776. So if I expand out the left-hand side, I'm going to get x squared. What have we got? X squared, sorry, 2x squared minus 108x minus 1134 is equal to 776. And actually, I don't really fancy factorising that. It looks a bit messy. So what I'm going to do is use quadratic formula. So x is equal to, actually, first of all, I need to make it equal to 0, don't I? So 2x squared minus 108x. And then, again, bring my calculator in. 776, I'm going to take that away from both sides. So let's clear that. Negative 1134, take away 7776. Press equals, you get yourself negative 8,910 equals 0. And again, I'm just going to use my quadratic formula here. So x is equal to the negative of negative of b, which is positive 108, plus or minus the square root of b squared, so that's 108 squared, or negative 108 squared, minus 4 times by a times c, so that's negative 4 times by a times by c. Okay, if you wanted to do negative, you should have done that. And then all divided by 2 times 2. Okay, and again, I'm just going to stick that into a calculator and see what the values come out as. So I'm going to clear that. I'm going to put a calculator button in, fraction button in. I'm going to go 108, then I'm going to type plus square root of 108 squared. Okay, again, if I wanted to put brackets in here to make it negative, that's up to you, but I know that a negative number squared is just going to be positive anyway, so I'm being a little bit lazy just for the sake of coming to the end of the exam. And then negative 4 times by 2 times by, and then just make sure I use my brackets again, negative 8,910, and then come out of that square root and go on the denominator, then 2 times 2, or I could just type 4 if I prefer, and that gives me 99 as one value. So I've got x is equal to 99. If I go back and put a negative value in here, so I go back, all the way across, and I change this to a negative and press equals, I get negative 45. So two values here are x is equal to 99 or x equal to negative 45. Well, if you have a look here, there's only one value that's valid. Remember, it's a logarithm equation, so I can only put a positive number into my logarithm. So log of something, that number in there has got to be positive. Now, clearly, if I put negative 45 in here, that first logarithm isn't going to be valid, but 99 in here is valid in both logarithms. So as a result, the correct answer is x equals 99 only. Okay, so there we go. So 1 hour 31 minutes is basically what we're on at the moment, or just shy of 1 hour 32, I think. That's how long it took for me to go through this paper. Now, obviously, I appreciate, like, I've been doing this for many, many years, and I also sort of helped to compile the paper as well, so I saw it beforehand, and I'm not under an exam. So, but the fact that I completed this in an hour and 45 minutes, an hour and 30 minutes, shows that actually, you know, you would have had at least 30 minutes spare if you were going at the same pace of me, and I'm explaining things at the same time. Okay, so I appreciate that, you know, some people were rushing towards the end. Again, this is just practice. Okay. A lot of these questions, which again I will emphasise because I was really, really disappointed with the performance on this paper overall actually. A lot of these questions were standard questions, which we have done many, many, many examples of in class, okay? So the fact that there were just basic arithmetic errors, just basic accuracy errors, just really shouldn't have happened. It just, for me, shows that there's been a lack of practice taking place here and that a lot of people just kind of thought they could get away with the bare minimum, and that really, really showed with this paper, okay? So if you did work hard, thank you. If you didn't work hard, then, or if you felt like you could do a lot more, then hopefully this is sort of a wake-up call, because you will have an opportunity to resit, and there will also be the opportunity at the end of the module exam to do well as well there, and that's worth more, that's worth 60%, okay? So now you've got used to the style of these exams and kind of the standard of the questions. Hopefully that gives you a bit more of an idea, okay? If you have any questions, or if there's anything that you want to go over again, obviously you can ask me either by email over the Christmas break, or you can sort of wait until we come back after Christmas, and then we can sort of go through things there. The vast majority of people, there's a high number of people that will need to resit this exam. Remember, 40% is the pass mark. Some people were close and not quite there. Other people, I think, will be disappointed with their grades, okay? Again, I just want to re-emphasise, I will give you qualitative feedback written as well. I just want to re-emphasise that hopefully by now, by the time we've gone through this paper, hopefully you realise that a lot of these questions were accessible. There were definitely harder questions in here. So for example, if I look at the quadratic section, I think quadratic section B was actually quite a tricky question because it was recognising that this is what was needed. So okay, you might not have got all the marks there. And there were a couple of other sort of slightly trickier questions, but I think overall this was a fair paper. Okay, and hopefully now we've gone through it, you realise that a lot of these questions are at least similar to, if not like for questions that we've done in class. Okay, so hopefully now you've gone through that, hopefully now kind of realise where your errors are. What I recommend that you do as a good source of revision is actually have a go at this paper again yourself in your own time. Okay, so actually go through these questions and practice the style of these questions. You've got all the answers in front of you now, you've gone through things with me, and hopefully that's a good source of revision. But also, if you know you're going to have to resit, so if you've got below 30%, so if you've got below 40%, you will have to resit this paper. So hopefully that will kind of prepare you, and over the Christmas break you can kind of do the practice which you need to get there. Okay. Of course, if any questions, drop me a message. That brings me sort of to 1 hour and 35 for this video. Yeah, have a good Christmas break, everyone. I'll see you all in January.